Very good morning, everyone, and welcome you all to the second day of our GIAN course titled Thermochemical Conversion of Biomass Waste to Bioenergy and Value-Added Products. Hearty welcome to both offline participants and online participants as well. Now I request Professor Ong to continue with the session.
Hello, can you hear me? Okay. Welcome back to the second days of our courses. So far, any feedback, any suggestions that you want to give before I start the lectures for today? I still can follow everyone. I still can follow. So have enough sleep. Yeah, okay. So without any further ado, I will start the lecture for the today. So before I start the topic, so I would like to share these figures for you to think, because every time before I start my lectures, I like to throw out some problem that we don't have one definite solution yet, solution. So the today topic is about energy and waters. Why energy and waters? So these two resources are very essential for the human beings, because everyone we need what energy. Need energy for what? For education. Without energy, no education, no lighting system, nothing. So for education. Secondly, for what? Healthcare system. Healthcare system. Without the health, we cannot do anything. And after that is for your living, for your entertainment, for everything, and all our living life. We need the energy. And also the waters is also very important. Water is more important for what? The plantations, the food, the sort of the food, the drinking waters. And also we need water to produce what? Energy for the cooling plant, correct or not? For the cooling plant. At the same time, we need the energy to produce the clean water. But these two resources are limiting each another. So how we going to have the sustainable water and sustainable energy? So any solution for that? Because you see, we need both. We need both, at the same time, we need both. But they are limiting each another. Limiting each another means what? We need the energy to produce the waters. And we need the waters to produce the energy. And both resources are what? Limited. Then sometimes not sustainable, correct not? Not sustainable. Some of the location, lack of water, lack of electricity, correct not? So how we going to make sure we have the sustainable clean water and sustainable clean energy? That is the thing that we all need to think, because all of you are what? Scientists. Some of you are scientists, scholars, research scholars, engineers, correct not? So for us to think how we going to have these two resources, since these two resources are running short anywhere, because the demand of these two resources are definitely will be increasing day by day, and due to what? The populations, the increasing of our living lifestyle as well, right not? Yep, that's the thing. So any feedback, any comments on this? So how we going to have the sustainable green water, sustainable green energy? It's one of the way. Yeah, it's one of the way. Yeah, it's one of the way. Correct. Because for us at this generation, we are so fortunate because we don't need to think these two resources. These two are automatically on switch. We have electricity. We didn't think how it's come from. Correct not? Tap water, open the tap water. We have the clean water already. Correct not? We never think how it's come from. Yeah, how it come from. These two precious resources. And sometimes we let the electricity just switch on, just wasted like this only. Similar for the water. That's the thing. We need to think of then how precious these two resources. So yeah, before I start the topic, I already categorized what will be covered in these courses. Again, first topic is about the biofuel and bioenergy, which I already started on the liquid fuels, which is what is the biodiesel and what is the bioethanol. Biodiesel and bioethanol, the focus more on the liquid fuels, so that you are more clear about that. And also we use the advanced technologies. Advanced technologies, that means the technologies that we use for our study is microwave, ultrasound. We use the catalytic reaction and so on and so forth. At the same time, we in our group we further upgrade the liquid fuel into the biojet fuel or the sustainable aviation fuels. This one we started in 2018. We started to study the potentials of converting this biomass waste into the what? Into the biojet fuel. Of course, we are facing some problem. Some of the property cannot fulfill. Then later on I will discuss in details. So the process we are looking for is the single step. There are many other technologies can be converted into the biojet fuel, but what we are looking for is the single step. One step directly, one pot, one step to convert into the biojet fuels. Of course, we will cover the thermochemical conversion process, which my main focus, personally, my main focus is the pyrolysis and torrefactions. So I believe most of you heard about the pyrolysis, know about the pyrolysis. So any one of you don't know what is pyrolysis? It's one of the very common thermochemical conversion process. Then the torrefactions. So how many of you know what is the torrefactions? Torrefactions. Sorry? What temperature? Lower temperature. Yes, it's a lower temperature. Yes, below 300. Yes, correct. So torrefaction is relatively we can say the mild pyrolysis with lower temperature. Why? Because why? The people some don't want to use the the pyrolysis process or even the gasification process because the temperature is relatively high. High, that means easily more than 500 degrees C. And the minimum is 500 degrees C for the pyrolysis because it's one of the very energy consumption process. And while the product we get maybe sometimes unable to recover back whatever the energy input. That means the imbalance between the output and input. So that's why we have the torrefaction process, which is one of the relatively mild pyrolysis. I can say mild pyrolysis because the reaction temperatures can be between 150, 60 to 300 degrees C. Of course, we have the hydrothermal. I guess all of you know what is hydrothermal. Hydrothermal, that means hydro with water, involved with the water. Thermal, hydrothermal, that means steer, heating. So hydrothermal it must be deal with some pressure because if we have the water in one of the closed systems, the pressure automatically will be increased. So for the hydrothermals, normally in the industry, we are using the relatively low temperature. Why? Because if we use the high temperature, we can use the high temperature, but your reactor, the result of your reactors must be enough to stand for the high pressure because when you hit things, the pressure automatically will be increased. So how are you going to reduce that pressure? So yep, because if high pressure, the idea is from the scientific point of view, the idea is high temperature, high pressure is very good for any reactions. Any reaction is very good. You will get a very pure substance or pure products, without adding any chemicals or any solvents into your reactions. But due to the very high initial cost, so we need to take the balance between high initial cost. Why high initial cost? Because the high temperatures you need the special design reactor that can stand that high pressures. That's the thing. Then secondly, during the maintenance also very relatively high. If we deal with the high temperature and high pressure, that's the thing. The industry is less. The third one is what? Safety problem. Safety problem. So anything happens with the high temperature, high pressures, will be cause a very serious safety issues. So hydrothermals and also wet torrefaction. Similarly, when we see the word torrefaction, it means relatively low temperature. I mean we can say the low temperatures hydrothermal, which normally is working on the around below 200 degrees C, is around 160 and 170 because the pressure is relatively low at that temperature. If we taking water as a medium, if it reacts at around 160 to 170, the pressure might be 10 bar only. 10 bar, which is 10 times of the atmosphere pressure, which is relatively low. So normally, the current industry, they using these temperature and pressures for their hydrothermal reactions. Of course, we also will discuss the co-pyrolysis, co-torrefactions, and also the co-products. Co-products, I mean what? I think I already discussed yesterday. For any hydrothermal reaction, or not necessarily hydrothermal, for any reactions, you have your main products that you want to focus on, but at the same time, the byproduct will produce as well. See whether depend on your focus on the product and also your process, and also what is your main focus of the product. See whether you want to recover the byproduct or not. Sometimes we not necessary to recover the byproduct, because the byproduct might be helping in the main product as well. Or sometimes your byproduct will be limiting your main product. For example, the byproduct will reduce maybe the energy content, for example, or will we have the negative effects on your combustion. So we might think on to recover back, recover the byproduct. Or sometimes we found that your raw materials, or your feedstock have a certain compound. We don't know, we got certain compound. Maybe that compound will we have the negative impact on your process, sometimes that we not aware about that. So maybe before we start that reactions, the hydrothermal reaction or any reaction, we can maybe recover or separate that a small amount of the we cannot say the impurities, because it's already together with your main product, with your biomass. Maybe you can recover back for others value added product or others purpose, and before we proceed with the process. So that's why it's very important to see what is the physiochemical properties or the detailed characteristics of your products, of your raw material, not only product, the raw material, before we start the reaction. You can start the reaction first or whatever process first, but you see, after we remove this byproduct, what is the effect on your final product? That's the thing. Yeah, after that, the first one, if we focus on the liquid fuel, liquid product, then we also will focus on the solid product, which is the biochar. So the solid products in our team, we use the solid product as the solid fuel. Solid fuel is the characteristic values or the energy content for the solid product is high, so we can directly use as the solid fuel. And or we also exploring the potentials of the application of the solid product, which is can be used as the biofertilizer or bioabsorbent. Yep. So can see further studies. And lastly, normally after we conduct the whole process of the industry process, so we like to have the life cycle analysis. See what is the emission balance. So whether you have produced more emissions throughout the process or not, or you can have the net zero emissions, or we have the negative emissions. Sometimes we can have the negative emissions. Then followed by the techno-economic analysis. See what is the economical feasibility and what is the payback period by taking maybe the project lifetime of maybe 20 years. So what is the payback period? This is what we also covered in our study in our lab. So this one is we work toward the circular economy, because previously what we conduct only one line. It means from the raw material, throughout the process, then finally we get the product. Maybe we study the life cycle analysis of technology for this process only, for this individual process only. But we can see the overall circular economy, how each byproduct or each process can have maybe some waste. How can we recover the waste to convert it into the other type of the value added products during the process. So later on I will show you how we're going to make it circular. What is mean by the circular? Circular is not only recycling what remaining product or convert the remaining product what for the overall process. Yeah, for the overall process. So this is this few slide. I will show you the overall of our study. The first one, this one I think I already show you, which is the basically more on the biofuel. This is our lab. This is our lab. So basically, what we do is we convert the biomass waste, secondary son. These all are the waste, biomass waste. Convert it into the biofuel. Biofuel, which we focus more on the biodiesel, followed by the bioethanol. Bioethanol. We study the parameter studies, the qualities and also the yields of the products. After we convert it, we do the optimizations. Optimization. What is the optimal process for the lab scale and for the pilot scale? Because sometimes we want to upscale. The parameter might be different, might be changed, and the overall life cycle analysis or life cycle cost might be changed as well. You know, if from the lab scale and for the pilot scale. Because for the lab scale, what we want to do is to proof of concept. Oh, this technology is work. Then after that we need to think how to upscale, how to upscale it. So first thing is about the liquid fuel, liquid fuels from the non-edible oil. Then after that, we further upgrade the liquid fuels into the biojet fuel. This one we conduct these studies before the COVID. You know, before the COVID, people travel around the world, right? The air transport is increasing year by year, and also the emissions from the air transport is also increasing. So you see in 2019, they plan to implement 0.1% of the sustainable aviation fuel. Sustainable aviation fuel, that means what? Is the totally green fuel, not using the jet air one. Jet air one is a fossil aviation fuel, so it's 0.1%. But now they want to implement at least I don't know how many percent. If not mistaken, it's 5% before the aeroplane can be taken off. So that's why. So this one we started the study in 2018. What we do? Selection of the feedstock. We want to select what is the suitable raw material to be converted into the biojet fuel. Because if you know about the sustainable fuel, the carbon numbers shouldn't be more than C16, because most of the biomass feedstock they have the carbon change of the between C12 to C20, even up to C24. So we need to select the feedstock that have the shorter carbon change or carbon numbers. That's the thing that we want to study. So we need to study the suitable feedstock. And also one thing is very important. You see the freezing point. For the normal biofuel, the freezing point is around the maximum also -20. But for the jet air one fuel, they require up to 40. That is another property that we need to consider. Then the other is almost similar. If we are able to get the short carbon change, the density automatically will be reduced. Because for the normal biofuel, actually for the sustainable aviation fuel is almost similar with the green bioreserve, but the property is different. The fuel you look by the eyes is almost the same, but the properties is totally different. So that's why the process might be different to crack the carbon change into the shorter carbon change. The process must be able to do so. That's the thing. And also the freezing point. While we need to maintain the heating value. So this is our target. Yep. No. Jet fuel is slightly higher. I think it is more than that. Oh, India is the same. In India it's almost that, but in many countries for the sustainable aviation fuel it's much more higher price. Because with the support of the government or whatever. So if this is sustainable aviation fuel, they can get the subsidies for at this moment. Because why? Subsidy is important. You know what? At the very beginning, to encourage the factory to produce the sustainable fuel. Because with they have all the instrument and equipment, then they can further reduce the overall production price. If not, no one want to start. Yes. Oh, that means the Jet Air fuel. I mean, with the SAV, yes, they had some difference. They have some different at least for the EU. They are some different. So that's why many developing countries they are exporting their SAF to the European. Because why? They are very support this policy. So that's why their price much more higher at this moment. Because why? They already regulated, if not mistaken, I'm not sure how many percent already, if not mistaken, 5% by this year before their aeroplane can be taken off. So that's why no matter what is the cost, they have to buy at this moment. You can just Google. So yeah. So that's the thing. Yeah. So we need to see what is a suitable feedstock. Then currently we found that the used cooking oil or waste cooking oil might be suitable. So currently in the industry, many of them is converting the waste cooking oil into the sustainable aviation fuel. Yep. So we already have technologies. So how, like yesterday, what I discussed, how we going to mix the overall process price lower. That's the thing that we need to think of. Then selection of the catalyst, because the sustainable aviation is different, the process is different. It needs to use the catalyst to break out the carbon change, the long carbon change. Then of the reacting temperatures, like your process temperatures and amount of the catalyst that you want to use. And finally, the selection of the effective procedure. There are many technology and many procedures. And also we need to study what is the percentage of the selectivities. You know, many studies or researchers they think that they are able to produce the sustainable aviation fuel or jet aviation fuel or the green diesel. Green diesel also one of the name of the sustainable aviation fuel. But they only focus on the what? Model compound. Model compound means what? They select a certain model compound. Of course, they can produce a very pure sustainable aviation fuel. But in the real life industry, it is impossible, correct or not? So how we going to convert this biomass into the sustainable fuel? Because our group is we are not using the model compound. We are using the biomass waste. But of course, currently the result is not desirable yet. But with the missing, I mean If missing, I didn't show you the result, because that one I will show you in detail, because today is just a brief instructions on all the processes I will cover. So with the mix, with the certain percent, I don't know, between 5 to 10%, I don't know how many percent already. Yeah, then it can fulfill the standard with a certain percent. Oh, it is very important for the jet fuel. Jet fuel. Why? Why? Few reason. You look at the density. The densities for the jet air fuel is relatively low compared to the normal biodiesel, or your green diesel, or your green fuel, or whatever you want to name it, is relatively low. Why relatively low? Why we need low? Because we want to have the more energy content per liter or per meter cube of the energy storage. High energy storage content, so that's why. Correct, lighter fuel. Yes, we want to maintain the lighter fuel, because if you take together with aeroplane, we want the lighter fuel. Lighter fuel while maintaining with the what? The heating value, so that he can store more energy content per meter cube. Per meter cube. So that's why with this we need the low carbon change number. Yeah, that's the thing. Correct. Ah, yes, correct. Uh, no, no, because if more and more, some carbon is cracking to be the small carbon change. But if we are content a lot of the impurities, it's true. Yeah, correct, correct, correct. We need to filter up this impurity first. A lot of the impurities, a lot of impurities. Correct. Still, currently in the industry, a lot are using the used cooking oil. Yes, waste cooking oil, the used cooking oil. Yes, correct. Now at this moment. So then the next question is, how you going to correct the sufficient amount of the used cooking oil so that it fulfill the what economical feasibility, correct? We want the corrections, maybe the cost of the corrections, or the energy for the correction is more than that. That one you have to think how to make it feasible, because for the different region, different location, okay, the different way for you to correct. Then think of the way, then how to make it possible. That is your business secret or business plan. That's the thing. Because as I told you yesterday, many things, the technology is already there. Then how you find the solution to solve it, or how you package it. Okay, I give you another example. Currently, everyone say want to do the AI automation, control system, correct or not? But all the technology already there. Then how you going to take out the suitable components, make it and package it become one product? For example, laptop computers. Laptop or computer. Okay, we take the laptop. You see, this one, the chip. If we already have the motherboard chipset, we have a processor. Then the first person that can combine this one together become one product. Then he can be success. Then another person, maybe, I combine, I become smaller, more user friendly. That's the thing. The technology that one is more on the what? Industry design, process design person. So this is what I done in Taiwan, because they are very good in the industry process design. How to take the component part to redesign, become one of the brand new product that can bring the convenience to the user. This is how you can earn the money. Chip and component, how to combine it together. That's the thing. This is what. So how to correct the oil? This one you have to think your business plan, because it's the totally different for any region. Even within the India, maybe the West India and North India is totally different way for you to correct. Maybe sometime, maybe might be the same, might be the difference. Yeah, might have the totally different business plan. That's the thing. So you have to think the technology already there, because we as scientists or engineers, so we discover the process and technology. Then how we going to cross the last 1 mile to make it commercialized. That is the thing. To make it different. This is what we all need to think. So for those master and PhD scholar, of course, your main task is to discover the new knowledge, the new technology, to make sure this technology is feasible, to discover something new. Yes, of course. Then after you discover, then you think of how we're going to convert it into your commercial plans. There are many success stories. I can share with you some. One of my friends, he is the material engineer. During his master, he recovered one way to discover one way to extract the heavy metal from waste, from one type of waste. She recover one of the way to extract up the heavy metals, the waste totally no value. People want to throw away, want to get rid of it, but he found a way. But this is the new recovery. If he cannot turn into the business plan, that is the new discovery is very good. It's very good as well. But how we going to turn? Then he know, oh, he need to think of the way how can I correct this waste with the minimum cost. Then how I can, he has a technique already. Then how he can make this commercial process become the commercial process, to turn into a commercial process. Then to sell the what? Sell the heavy metal. The heavy metal is the what? The removal technique. Yeah, that's the thing. This is how we're going to turn. So sometimes you recover because we recover for those working on the maybe wastewater recovery. You want to remove the heavy metal, remove the whatever, and some of the compound. If you find a compound is maybe the percentage high. Percentage high mean high. Here is more than 10%. More than 10%, you can make it profit already. But provided that compound that you recover is useful for the certain industry process. That's the thing. It's value for the certain industry process. That's the thing. This is another way. There are many. The small things you can do. 20 year back, the waste tire, the wheel, the waste tire. You see, if you have the car or motorcycles of anything, every 2 years, you want to change your wheel, right? Car have 4 wheels, motorcycle have 2 wheels. People just throw, right? Not. And sometimes the tire shop ask you, I pay you maybe $1, $2. You help me to throw up throw the tire. Then that one is possible to convert it into the bio oil and also the biochar. That one you can make it. That is the thing. How to solve the people problem, and how to develop one product that can bring the convenience to the community. Convenient to the community. Then that's the thing. Like maybe 60, 70 years ago, we have the KFC, McDonald's. Why? Because they make the food fast, efficient for the user. Can I not? Food, everyone can cook, right? During that time, then people not really tend to buy the food outside, but they make it possible because make it convenient. Then the quality can be controlled. Mean every piece of the chicken they fried, same taste. Can I not? Yeah. That's the thing. So that's the thing. So this one, go back to our topic, aviation fuels. So this is what we do. So here we propose two process. Two process is almost similar. One is without pressure. One is with pressure. With the pressures. We use the nitrogen gas. The process we are using is the oxygenations. To remove the OH, then replace with the H. Then we select the feedstock, select the catalyst. Then in that study, we just use the commercial catalyst. So if you are able to design one catalyst that's useful for the process, then it might be better. What is the temperature? Then after that, of course, before we can use, we must compare with the ISTN standard, make it possible. So this is the check L1 field or two process. The function of the catalyst for those chemical, they can answer because the catalyst able to enhance the one of the very common definition of the catalyst is enhance the overall process, chemical process. Enhance means make it more efficient, or second it make it higher so that you can push the certain process towards that direction. For example, for any process, any thermochemical process or any chemical process, during one process, maybe there are 3 or 4 or 5 process might be happen concurrently. So, but you want a certain process only, maybe process A only. With the help of the catalyst, we can enhance the process A, so we can reduce the reaction for the process B and C. That one is the catalyst, the function of catalyst. Yeah, in general, yeah, that's the thing. So we must design one catalyst can push your process towards the product that you want. Yes, that's the thing. Increase the overall rate, increase the yield, or sometimes increase the purities of your product. Quality also, quality of your product. So it really depends. Each process has the different catalyst. Of course, we have the certain common catalyst. For example, in our chemical process, the chloride is one of the very common catalyst in most of the process. Correct or not? Chloride. Then with the chloride, then you can put in embedded with the other maybe heavy metal, whatever, to boost your certain process that you want. That's the thing. Chloride is one of the very common catalysts using in the industry nowadays. Yep. Calcium oxide also. Yep. Sorry? In this process, we try of the common commercial catalyst without any modification, because this is our primary studies. So we found that I can't remember already. That one I need to go back to my side. This one is connected. So if Zora, yes, the common use catalyst for the some deoxygenation process or some other green fuels production process. Chloride is a very common, but normally they embedded the chloride with one of the heavy metals. Heavy metal. Yeah, not using the Of course, this one I mentioned the chloride is without the activation. Yeah. One thing is you need to activate. This one is all the chemical things. You need to activate your catalyst first before it can be used. Activate. The activate meanings what? You make the catalyst suitable for that process before activation. Activations mean make it active catalyst. Yes. Okay. Sometimes for me I didn't study in details what is the color difference, but sometimes color might be different, but the property are similar because it depends on the feedstock, the raw material. Sometimes it depends on the raw material only. Then sometimes it's the black one. Of course, obviously they have some impurities already. Maybe sometimes it doesn't affect the overall product. Sometimes it's yes, sometimes it's not. Yeah, color is, for me, it's not really have the much effect. We need to see the overall properties, the and properties. Yep. Mainly, I can tell you is the color is basically based on the raw materials. Density, I think, does not have much effect on the colors. Sulfur, for the biofuel, the sulfur content almost zero. No sulfur content. So that's why that is the benefit. Biofuel almost don't have the sulfur, but they have the N. the nitrogen, nitrate can be formed the nitrate nitrogen because these are organic products. Organic product we have the nitrogen or compound, N compound, and for the all the biomass, most of the biomass, we have few compound, few very common compound: C, carbon, hydrogen, N, and O. This one. So that's why the biofuel sometimes will produce more NOx, NOx. So because why? Initially the biomass, biomass have the nitrogen compound. That is the thing. Nitrogen. Sulfur don't have. Only the fossil have the sulfur. Yeah. Fossil. Correct. Yes, correct. Yes. Correct. True also. Because true also. So before the industry process, we need to do the pre-treatment. Yeah, pre-treatment. Sometimes we need the pre-treatment. Pre-treatment like the regumming process or whatever process that necessary. Yes, you are right. Make the colors better. Yes. They have the way as well. Yes. Correct. Yeah, correct. Then sometimes some of the bio oil is very hard to burn. So we have the way to increase the ignition point to have the lower ignition point. Sometimes the ignition point is very high. Ignition point is high, that means we need the higher temperatures so that it can be burned. That is the thing. Yes, correct. Have because sometimes for the industry process because the feedstock maybe they have the slightly different property. The product might be different. Slightly, especially we are using the waste as the material. That is the thing. We are using the waste as a material. So yeah, still we are using the few type of the feedstock. We still found that the waste cooking oil and the palm is the suitable candidate for the jet fuel. Now this one in this study we focus more on the solid product. We focus on the solid product, which is the biochar. In that study, we use the wet torrefaction process. Which is the mild hydrothermal process or wet hydrothermal process. For this conversion, because in this study we are using a few type of the waste materials. The main materials we are using is the microalgae. Normally the microalgae are in the wet form, so we don't want to have the drying process. So that's why we think of this process whether it's suitable or not or feasible or not. What we do on that this study. Yesterday I think I briefly explained already. The pharmaceuticals companies they culture the algae. Then they extract the protein content or some pharmaceutical compound that useful for the applications. And after that, the leftover biomass. So we take it to recover some of the biofuel or the biochar, and then see what is the applications for the biofuel and biochar. So in that study, initially our focus is biochar only. But we found that there are a lot of the liquid hydrolysis product. We found what is the compound and component of the liquid product. We found that the liquid product have very high reducing sugar. If we have the high reducing sugar, is we can convert it into what? Ethanol. Bioethanol. So this study, we convert two products. Main product is the biochar, then the liquid product we convert it into the bioethanol. So we study what is the thermal behaviors of the biochar as the solid fuel or other application. After that, we further study. So what is the suitable applications for the biochar? We try a few applications. First is we can use it as a solid fuel, as a bioabsorbent. They accept some wastewater, and also can be used as the biofertilizer. Biofertilizer can be used directly, then or it can be the house for the what? Some bacteria. Can be housings for some of the bacteria, useful bacteria for your plantations. Because if we just put the fertilizer directly, maybe it will be after the raining day, the what? Your fertilizer will be go away. So the biochar is one of the very good medium to trap your fertilizer. It can be used as a biofertilizer as well, and also the bioabsorbent. Yes, we no need to dry. No need to dry. No need to dry. Later I'll show you. Yeah. Yes. Normally we grow in the fresh water. See, fresh water. Now I have the projects. They plan to grow into the sea water, because we no need to use the fresh water. See how can we study the stress behavior, whether it can overcome to live in the sea water or not. See what is the stress behavior. This is what we want to study, because why? It can culture in the sea water, then you can culture it. Highest year is compared to other type of the field. Yes, higher in terms of what? Per hectare of the land. Highest that means what? For the Jatopa, it's around 1000 kg per hectare. 1000 to 1005. Palm around 4 to 5000. Higher, so that's why palm is variable. Then this one more than 10,000 per hectare, but they have their own problem. I don't want to tell you now. They have their own problem. Microalgae is the highest, I can say. Per hectares of the land is highest. Yeah. No, what is your question? Your question is correct. Yeah. No matter what you want to name it, this is just a name only. So some people name it as a hydrochar. It's a precise name is a hydrochar. Yeah, whatever that you want to name, this is just the name, like the torrefaction. If for me, I can say this is a mild pyrolysis process. It's just the name. Then sometimes people tell it the hydrothermal carbonizations. Why? Because they focus on the carbonizations products. So the concept still the same. So in our lab, we design our own reactor, own process. So no matter what we want to name it, we want to make the process success only. What is the name? Name is what? The company. Oh, this equipment is for the hydrothermal carbonization. This equipment is for the wet. Actually, the concept is almost similar. You can modify or whatever. But if you buy directly, without knowing what is the concept and fundamental behind, you cannot modify, cannot play around. Then you cannot get the unexpected product. Sometimes the unexpected product is the product that variable, you know. If you just follow the very commercial process, so you know definite what is the product already. So what is the research, the spirit of the research come from? Nothing. So normally we design our own process. So no matter what I want to name, my reactor I can name it as a gasifier, pyrolysis, same thing. The concept is same thing. I just focus on different product only for me. But you don't tell your lecturer or whatever. This all I say because for them, your professor, your lecturer need to teach you all. The process is different. Yes, it is different. The equipment and instrument, yes, it is different. Different from different product, different for different project process, and different from different final product that you want. It's different. But for me, because I discover whatever the equipment I want to name it. Maybe no any name because my process I modify the process A, B, C, mix together or whatever. We play around with many process. So whatever you want to name it, the solid can we name it the biochar, hydrochar, or whatever name that you want to name it. Yep. So I look back the characteristic, the fundamentals of the product, or what is the characteristic of that product. Yeah, that is the difference. Of course it's different. Of course it's different. Correct. But how you going to define the biochar? What is the surface area for the biochar? What is the size of the biochar? Correct. 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 Yeah, you are right because you're focused on the biochar. So you want to get a certain property. You already have the concept. I want to design my process so that I can get the certain characteristic of the biochar property. Yes, you're right. Because your focus is on the biochar. Then you have to design your process to obtain that property of the biochar or your product, or you can name it any product by your name. Yep, correct. Not? Yes, correct. We do agree. Yes, correct. You're right. Okay, the ratio. For my study, we also study the different ratio. It depends on you. So again, back to that method question. It depends on what is the process, what is the final product that you want to design. At the ratio, I cannot tell you one ratio. You have to try up the ratio that you want so that you can get your desired final product. Understand or not? Different process, different characteristics, different process, different parameter, different temperatures. Even the different ratio from the experiment. Of course, we must have one standard benchmarking study. For example, a certain percentage. This is the percentage. Then maybe 10% of the liquid, 20, 30, 40, 50. Then see what is the difference. So we are doing the discovery works, research works. Then after that, we found that, oh, this one maybe 30%. We found the product is a very unique product, can be used for maybe application A, B, C, A. Then we further study, further improve the process so that we can get and design to get the product A. Example, for the certain purpose, or maybe as the bioabsorbents, for the maybe for the wastewater, for the industry wastewater, maybe for the semiconductor wastewater, to recover back the heavy metal. Example, then we can design toward that things. Then we'll design the process. So during the discovery, for us, our group, we just let it open. We try any possible how to treat the waste so that we can get more value added products. Yep. Yes. Correct. That is another problem I face. Microalgae, this one I told you. I didn't say the microalgae is a good product, the definite product for the certain things, I just introduce you with the microalgae. As I mentioned just now, microalgae to convert into biofuel facing the certain difficulty as well. Facing the second advantage, even though he has the highest, I can say green metal highest yield for hectare of the land. of the land. Yeah, is the highest. But the overall yield is very less, you know. You will get more biomass compared to the bio oil. Even per land area is a lot. Yeah, that's the thing. They are facing the challenges. So these all challenges we need to find a way to overcome. That's the thing. Yeah, correct. So that's why people even modify the microalgae, modify so that it can be suitable for certain thing. And also yeah, another problem, the contamination will be happen because it deal with the microalgae. It's a microbe, one type of microbe. So the easily get contamination. One contamination, the whole pond cannot be used. That's another challenge that you have to overcome. Then the good thing about the microalgae is what we can say is a net zero process. Why net zero? Because it consumes CO2 to grow. Consume CO2 to grow, you know. We can say not only net zero, you can say negative, you know, negative emission because it consumes the CO2. Yeah, it really consume, very consume the CO2. It's one of the things about the microalgae. This one is another study. We have the stream wastewater. Stream wastewater. We use that stream wastewater to culture the microalgae. Because just now back to your question, whether the algae can be grown in the seawater or not or whatever. It every time we need to use the fresh water. Also consume a lot of the water resources. So we try to use some wastewater. Some wastewater. This study I conduct in the Taiwan. Taiwan. So we grow the microalgae using the stream wastewaters. Then after that, we found that the water can be treated, you know, by using the microalgae, and at the same time we can correct the microalgae biomass. Yeah, this one is kill. I think kill 3 stones. No, kill 3 birds in with 1 stone. First, the water can be treated. Then we have the microalgae. Microalgae is one of the absorbent of the CO2. Is consume the CO2 to grow microalgae. So we have the certain percentage of the protein. The protein can be extract out for any other purpose. Then the biomass can be further processed to produce the bio oil, bio crude oil. That one is bio crude oil. We stop until bio crude oil. The bio crude oil maybe can further process to produce the biofuel. To convert it into the biofuel. Then the biochar we also stop here, but we didn't further process, so we can study what is the properties for the biochar or hydrochar, because we are using the hydrothermal reaction. Yep, this is another study. We found that the COD can be removed by 92%. 92% if we use the stream wastewaters in the cultivations of the microalgae. And then the total phosphorus can be reduced by 93%, then the ammonia can be reduced by 95%. So this all can be one of the nutrients for the microalgae. Yep. Any questions about this? COD is the compound oxidant. Chemical oxidant compound. Oxidant demand is one of the parameter to measure the wastewater. If higher COD, that means they are pollutants or indications. Yeah. Because that one, the wastewater have the certain nutrients. The certain nutrient can be one of the food for the microalgae. It consumes. Nutrition. Yep. Oh, that one. harvest. We go through the harvesting process. That one harvesting, but I didn't show you in details. Harvest. We need to harvest. No, we harvest it, sieve it, correct. Then store, then drying process. Go through the drying process. Yeah, that one, correct. But you see, when you look at the result, you have found one problem. You see, out of 1 liter, you only can get 6 grams only. There is a thing. There's another. Yes, yes, correct. 6 grams only. Yes. I mean, this one, hydrosomer to biochar. Feedstock no need to be dry. This one, for this process, no need to be dry. No. Okay. This one for the illusion purpose only. Okay. I want to clarify here. This one is only the simplified process. Later on, throughout this 3-4 days, I will discuss in detail each of the process. You know, this one is to let you know the overview. Overview. This one is only for the illustrations purpose only. We using the half dry microalgae. After harvest, we didn't go through the drying process. Drying process means we are not putting in the oven to dry it. Then this one are not our microalgae. This one is just the photo. Then we just use the wet biomass, microalgae biomass with the certain percentage of the liquid product. 5%, 10%. Of course, we take our benchmarking. So how to measure the 5%, 10%, 20% of the liquid product? Yeah, with a certain ratio. With a certain ratio. If you want to know more details, you can go to this study. Study will describe in very details the process. Yep. This one we are not drying. But just now back to that question, because I just explained how to make it to the dry powders. Totally dry powders. Yep. Correct. Yes. Correct. You know. After this one, the microalgae, the biomass, after we extract the lipid content, the protein content or whatever, this one can be another purpose is can be the animal feed. Animal feed. Animal feed, yeah. Many. Correct. Can be many other purposes. See what you want to focus on. Yes, correct. This is just one of the direction. Yes, correct. Yeah, right. Can be have the many purpose on the microalgae. Yes, yeah, right. True. No, open dry process most cost effective. Yeah. Here, currently, the open dry process is the most cost effective and most easier and direct process for this location have the sunlight. Of course, provided the location have the sunlight. Yeah, correct. The open dry process. Most of the industry still using, for the mass production of the biomass or whatever, they are still using the open drying process. Yes, unless the product you have to control product with the certain percentage, very precise certain percentage of the moisture content. Cannot have, then we will go through the industry process. After the open drying process, then we will go through the maybe the oven drying or whatever process to make sure the moisture content is lower to the certain limits. Yep. So this is one of the studies that I'll cover. Oh yeah, this one focus on biochar. This one is the thermochemical process. This one, what we are doing is, you see, like microalgae. We have our microalgae. We culture our microalgae to extract the protein or whatever the leftover. Mean we can go through the thermochemical process. And this one the jatopa the oil because from our previous research we using the jatopa to extract the oil, right? Not to extract the oil. Then after that the biomass waste. That's how what we're going to do. So we go through the thermochemical process, see what still have some value or not. So similarly, we try the spent coffee ground, go through the thermochemical process, then see what is the applications. This is the biochar that you mentioned, right? This is the process. Yeah, and its applications. So yeah, if in more precise, yeah, that one is the wet microalgae. This is a wet microalgae. We are modified using our household microwave for our experiment. For this experiment, household experiment. Why? Because the temperature distributions might be more accurate. Even now, I design another reactor so that we can study the heat maps. So whether it is the heat distribution equally or not. Correct. I can see the heat map of the so like what I mentioned, we like to design our own reactors. Reactor. Now I am still keep designing the reactors. The reactors. Then this one go through the wet torrefaction process. This one is the wet form. Not necessarily in this form. We do calculate how many percent, how many percent, not directly using. Then we calculate how many percent with the certain benchmarkings. Then go through the wet torrefaction process. Then with the nitrogen gas. Okay. One thing is very important. If you want to work on the thermochemical process, normally we have using some gas, correct not? For example, the nitrogen gas or whatever, so that they have no any oxygen, no oxygen, so that they can avoid the combustion process. If after the combustion, so your biochar or whatever has no value, or your product has no value, so you can use the nitrogen, can use the hydrogen. It depends on your final product. What is your final product that you want? So we go through the nitrogen. Then we have the solid biochar and liquid hydrolysis products. Then for the biochar, then we study the post-treatment analysis and ultimate analysis and see what is the compositions, the chemical compositions of the solid products. Then see the higher heating values. Then go through the TGA, see the degradation curve, thermal degradation curve. Then FTIL and SEN. Now look at what is the potential applications for the solid product. Not necessarily to be used as a solid fuel. Can be other purpose. Then for the liquid product, we found that you have the high total reducing sugar. So with the reducing sugar content, we able to convert it into the what? Bioethanol. So that's why we further do the fermentation process and to convert it into the bioethanol. Yep. Any question? Any comments? This one is another. This one is study. This study focus on gas product. Focus on gas product. In Malaysia, we have a lot of the palm oil meal effluents. We call it the POME. Palm oil meal effluent is the wastewater from the palm oil meal. So we go through the wet torrefaction process. We use the wet torrefaction process here as a pre-treatment only. Then after that, we use the torrefied POME. Go through the dark fermentations. You can produce the biogas. Biogas can be produced. Then after that, we also do the optimization study. So this is the gas product that we get. So for our group, I think yesterday I told you we focus a lot on the liquid product and also the solid product. Gas product is relatively new for our group. We just started 2-3 years ago. Yep, relatively new. So this is one of study that we focus on the gas products, biogas or the syngas that we able to produce. We also using any other type of the feedstock or raw materials to produce the syngas or even the biogas. But the overall yield is not very high, So that's why for me I prefer to use the biogas as a byproduct. I focus more on the liquid product and also the solid product. Then biogas I feed back to the reactors, so that the reactor no need to use the electricity. This is my target. Yeah. Can. Can. So after the process it can be used. Yes, can. Yeah, right. So that's why I biogas always is my byproduct. So now I want to study how I can utilize that byproducts. Yeah, how to study. So to feedback to here to the burner. If the industry process not this inside, it go through the burner to burn it. Yeah, go through the burners. So this one is more on the circular economics. Circular economy. This one I obtained from the Malaysian National Biomass Action Plan. We have the action plan. Yesterday I told you we have the action plan for 2023 to 2030. How we going to utilize the biomass that available in Malaysia to produce something, the biofuel, bioenergy, and some value-added product, not necessarily energy-related products. So you see, we have a lot of palm oil plantations in Malaysia. So the palm oil plantation, the fresh fresh branch of the palm oil sent to the palm oil mill. Then we have the empty fruit branch over there on your right hand side. This one. We have the empty fruit branch after processing. This is the biomass waste, empty fruit branch, and also the palm kernel. Palm kernel. And this one is the palm trunk and fronds. Then we send to the centralized correction centers. Then through up can distribute and through the different process. It can be used as a biofertilizer, sent to the biofertilizer after processing. Then can be sent to the biomass pellet plant. Biomass pellet plant, it means what? After processing the biomass, it can be used as solid fuel. Sent to the pellet plant, can generate some electricity. Then the semi-treated you can send to the next gen palm mill to produce the paper. Then can be used as animal feed like you mentioned. Then animal feed, then we have the wastewater treatment, and can be treated the waters. Then at the same time we can have the renewable energy sources. For the biogas plant, then the byproduct can be sent back to the fertilizer. This one you can using the solar energy. So this how we going to have the overall life cycles for the palm biomass correction and also the processing. Because if we look at the process in single line, it's not possible. The cost is much more higher. So how we need to make it feasible? Look at the overall. Like this one, overall circular economies. You see, we have the palm oil, empty fruit branch. Empty fruit branch have the pomace, have the fiber. Then you can send to the different process. There are different plants. And from the different plants, we can have the what? The green energy, for example, the solar energy, the bioelectric energy, or the biogas plants, or the solid biofuel plants to have it. Then some it can be the bio fertilizer to become the compost, and also go through the fermentation process, digester. Then this one can be used. Just now I mentioned the pomace, the palm oil meal effluent can be used as a microalgae cultivations in pomace, because at the same time you can treat the pomace, palm oil meal effluents. Then this one, the waste can be volatile to be the bioplastics or animal feed. And go back to overall cycle. See, so this is how we're going to utilize it to make it overall circular. Yeah, circular. Not only the single process we use, but make the overall circular economy. Yeah, this one is I adopted from one of the study. Yep. Yeah, this is the plan that we can work on this. Of course, for us as a researcher and a scholar, we must focus either here or either there. But we must have the big vision and mission so that we know what we are doing. So what is the problem thing? What is so every the contribution for every part is also very important. Very important. This one is the concept that from our government, our country since 2023, we are working toward in that direction. In that direction, want to utilize the biomass waste. Yeah, successful or not successful, we need to wait for another 3 to 5 years to see how is the effect. How the effect. Yeah. Yes. This is the last slide, I think. Okay lah, last slide. Yes. So like usual, this one is the world is moving toward the renewable energy to reduce the CO2 by 40% in 2015. So biomass is one of the potential. The biomass is not the only solution. It's one of the solutions. Don't take me wrong. Biomass is one of the solutions. Not the only solution. It's one of the solutions. Yep. Yeah. So then our job is how to make the overall process is sustainable, sustainable and green, so that we can turn this biomass waste into the sustainable energy or any type of the value-added product. So with this, I think we take a break for 15 minutes. Yep.
Hello all, we'll take a break for 15 minutes and we'll start the next session by 11:30. Please be Hello. Welcome back, everyone. We'll start our session now. The session will go until 1 o'clock. So after 1, we'll have a lunch break. Okay. May I request Professor Ong to start the session?
Hello. Just now I just go to overall of our studies and our findings. So before I continue with the particular study, so any questions or anything that you want to ask, yes, please. Okay. Yeah, for the yield of the, if you talking about the yield, what type of yield? There are three types of the yield. Yield of the liquid product, the solid product, and also the gas product. What is the yield that you mentioned? Okay. It's go back to your process design and also go back to your raw material. The process design. Why I say the process design? Because, for example, if your process you purposely design to get the high qualities of the biochar or the solid product, not necessarily biochar or the solid product. For example, you want the high quality of the solid product, then you pyrolysis at very high temperature, so that you can get a very formed the solid product of nice solid product. Then the yield might be less because you use the high temperature and you use the prolonged reaction time. It really depends. So the yield for the certain product is depend on your process and the raw materials. For example, you want to get the biochar, but what is the rule of thumb that we can know is, if the reaction time, if prolong the reaction time, of course the biochar will be reduced. Reduced. Then the bio oil will be increased, the gas will be increased. That's the thing. Then with the higher temperature also, the solid product will be reduced. This is the rule of thumb. But if you ask me certain percentage, it's really, I need to go back to experiments, different parameter, different process, different catalyst that you are using, different co-pyrolysis that you are using, or different raw materials you are using, totally different. It depends what you want to design. You design to get the bio oil, or you design to get the solid product. Then even you design to get your solid product, it also depends. What is the characteristic or property of the solid product that you want? Maybe you want a very fine carbon nanotube. You want to desire to be produced as the carbon nanotube light solid product. Maybe the parameter is different, and also the year is different. That's the thing. Hope I answer your question. Yep. Any other questions? Any other questions? Yes. Can. Yes, can. Higher, what I can say is one thing is a higher temperature, much more higher temperature. So for CNT, you want a very stable product with a very fine carbon nanotube. It become the nano particles. It's a tube form. Second thing, you need a certain catalyst to so that you can form the form. Yes. Then in the relatively high pressure, some pressure, not very high, some pressure, with some pressure, yes, can be the carbon nanotube. Carbon nanotube is everybody want to produce that things, because that one is more valuable compared to other things. So that one can be used as a what the electronics product part and component for the some electronic product. Yes, and that one is yeah, they are a lot of the, because a lot of the publications in the science natures that they are producing on that product, that my product. You can go and refer. Yeah, that one is the instrument equipment is totally different. For frankly say, for my process, I still unable to produce until that level yet. Yes, because previously I also have the vision to produce something like that. After I read the condition, still not yet. Yeah, yeah, and it's possible. It's possible. Yep. So any other questions? If not, then I will go to two very fundamental study. This one is two of my student work. So how I want to show you how the student, the master student, they turn the biomass waste into this some product. Then how they conduct their experiments, what is the parameters they study, then how they turn these parameters into the some output or events, the publications, and how they turn this publication into their PhD thesis. PhD thesis, you know. Yep. The two study is based on the ultrasound techniques. I discussed about the ultrasound this one. Using the ultrasound technique. In this study, what is the special of this study, or we can say the significant novelty in this study? So normally, when we talk about the biomass, we need to extract the liquid product, what we call the bio oil or the jatopa oil or the palm oil, the liquid product. Extract out the liquid product through various process. What is the various process? First one, much more easiest one or traditional process that we are using for maybe for the past 1,000 years is what? Mechanical pressing. That one you can really get the pure oil. Cannot, no matter it's from the rice oil, from any type of oil. That one is really pure oil. Yes, still until today, the industry is still using this process. I mean, one of the very common process is mechanical pressing process for the palm oil, for any type of oil, even for the coconut oil as well, using a mechanical pressing process. Second, you can use the chemical solvent extractions for the chemical students or the chemistry student, you know, right? The process, the solvent extractions. What is the solvent extractions? Solvent extraction is, for example, you have the certain biomass. You want to extract out maybe the oil. Example, the oil contents or the certain content. Then you take the solvent that can absorb the oil content. For example, if oil content, we can use the N-hexane or the methanol as a solvent. Then from that, the oil can be extracted out by using the solvent. For example, we take about the hexane, extract out from the hexane or methanol, and we evaporate out the solvent. Then the leftover is the compound and the component that you, or the product that you want to extract out. Now that is the second method. We have the many other method as well. In this study, we use the institute process from the extraction, and also the conversion. We do it together. So that as one step. So this is one of our work. Okay, the background. I don't want to go again. The background. I think most of you know about the background. Then the problem statement. There are two problem statements. First is the competition between the food and fuel. I don't want to go into detail. Then we go about the second generation of the oil. Then the second problem statement is what? The overall production process have to go through many process, step by step. The extraction, purification, esterification, transfication, purifications process. It takes around 70% of the total biodiesel production cost. Make the overall cost is highest. So that's why this is the conventional process. It's not economically feasible. So instead of we use the initial feedstock as the oil. I mean after the extraction, no matter the mechanical extractions or maybe the solvent extraction, but we use the in situ reactive extractions. I mean we use the feedstock directly, from these experiments to produce the research. Oh, I didn't show you the objective. Oh, objective here. Okay, because you see from the conventional process, the jatoplastics I need to go through the grinding and also the drying. I did still the same process. After that, we need to use the N-hexanes to extract the oil from the raw seeds. This one is using the chemical solvent extraction process. Then after that, we need to recover using the evaporator. Then after that, reactive. And this one, the reaction is go through two-step of reaction. I didn't show you here. The traditional need to go through the two-step of reaction. One is the acid catalyst esterification. The second step is the alkaline catalyst trans esterification process. Then before we can go to the gastro catalyst step. But our process we just using one step to replace these two steps into the one step, but the other step is almost similar. So the objective of this study is what? Investigate the feasibilities of the non-abrasives. In this study we are using the Jatopa for the in situ reactive extraction with ultrasound. Why ultrasound? So what is the benefit of ultrasound? Later show you. Then we study what is the effect of the parameters for the ultrasound assist in situ esterification. One is esterification, another one is transesterification process. Then lastly, we do the characterizations of the jatopacid before and after the ultrasound, and also the few properties of the biodiesel produced. This is one of my master student projects. So this for objective. Jatopa oil, I don't want to discuss in details which the oil year just I mentioned around 1,500 kg per hectare only. 1,500 kg per hectare, which widely distributed around the Southeast Asia and as well as in the Africa and India. The oil could be 30 to 40, 35 to 40% come from the seed and also the kernel. Kernel is higher. So this is the methodologies that we design. First is the pre-treatment process. This pre-treatment process because the jatopa oil, jatopa seed or jatopa oil is relatively green, compared to other type of the oil. Example, compared to the calophyllum, inoculum, we need to do a lot of the regamming, the purifications. But this jatopa oil, we didn't do much pre-treatment. We just grinding and also the drying only. After that, we go to the ultrasound assisted in situ esterification and trans esterification process without the extraction. But in this study, we are comparing both using the chemical solvent extraction and also the direct in situ process. See what is the difference. What is the difference in terms of the properties, or in terms of the yields, or in terms of the purities. Then after that, we compare. This is a physiochemical property that we will compare. Okay, I didn't go discussion into the detail. No, I directly go to the outcome first. If someone want to go into the detail about that study, you are feel free to go into that one. Is which study? And let me see. This study, the first study, all the detail result are from not this study. Or the last one, this study. The number 3 and number 1, 3 and 1. this study has 3 and 1. Two study. This one is the preliminary study, then followed by the this one, the process intensify of the biodiesel synthesis. These two studies for those interested, they can go to these two studies, because sometimes I didn't discuss in detail here. In detail here. Yes. Correct. 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 That one have to go back. Go back to your chemistry or chemicals courses. You need to identify what is the solvent for the certain products. That one they have the list. For me, because I always do with the oil, then I know what is the solvent for the oil. But for the different compound, they have the different solvent. There's a very standard different solvent, or you can design your own solvent as well. But they have the list of the very common solvent for the certain chemical compound that you want to extract out. They have the list. Yes, sometimes, because sometimes other things when we extract together, then make it impurities. That's why you have to choose the correct solvent and correct target products that you want. So that other unnecessary compound will not attract to come together. Yes, you're right. So you have to make sure that solvent only extract your targeted compound, but not other compound. If other compound is extracted, you need to know how to separate it, because sometimes cannot avoid. That is the only solvent that we have to extract this compound. But the compound B and C will come together. Then after that, how you going to separate the compound A with B and C? That one you have to further study. So that is your job to study, to investigate. Yeah, that's the thing. Yes, you're right. Correct. So this one I straight go to the result. Yes. Different. You mean the solvent? Solvent same. Sorry, solvent same. I mean the result outcome will be different. Solvent is the same. Solvent is the same. Yes, solvent is the same. Yes. Solvent is the same. Solvent means what? Solvent means that solvent can take out that target product or not. This is solvent. Yeah, the function of the solvent. You can take out the certain target products. That's the function of solvent, but it's the same. It's the same. Yeah. Your question is correct. Maybe sometime, the temperature might affect the solvent. For example, the boiling point for the methanol, will be evaporate at 60 degrees C. Make sure you don't heat more than 60 degrees C. If not, the methanol will be evaporate. That's the thing that you need to consider. If you use the methanol as a solvent example, evaporation might be happen. So how you need to make sure they are mixed well during the reaction, even though you want to use more than 60 degrees C. I didn't say cannot be used, but can be used. Yeah, because the evaporation might be happens. Yep. So yeah, this one I just go straight to the result. You see, for any research, positive result, negative result also one of the outcome. I didn't mean that you have to report all the negative result, but what I want to make you clear is the negative result is one of the result. One of the result throughout your master or your PhD or even your research. Because why? You can let people know this one is not working. But of course, for master and PhD, of course you have to come up with one set of the success experiments. You only can prove that. You cannot say, I do 10 set, 10 set also fail. What is your PhD work? Cannot be also. But the negative result also can be a result. as a benchmarking, as a comparison, as a comparison. That's one thing. So you say, this one. So effect of the, so sometimes we want to study the effect of the certain thing. Maybe they are not nothing much to change, but you show they are nothing much changing. You see this one is a what particulars particle size particle size we divide into the three categories. One is the particle size less than 1 mm, more than 2 mm, and between 1 and 2 mm. Between 1 and 2 mm, we found that this one we look at the effect on what extraction efficiency, esterification efficiency, frame year. What is that? Extraction efficiency is how many percent how many percent of the jet can be extract out. This one we call it the extraction efficiency. That means we calculate based on the total weight of the raw material. I mean the total oil that extracted divided by total weight of the raw materials. This one is the extraction efficiency. Esterification efficiency. So the main purpose of the esterification process is what? To reduce the acid value. To reduce the acid value. As I told you, the non-edible oil normally have the high acid value and high viscosity. So the esterification is there to reduce the acid value. This one, the acid value, how much really? I think it's 18. 18. 18 is 18. We want to reduce to below, if for the biodiesel below 0.2. 0.5. Then then the frame year. Frame year, I mean during the esterification, some of the triglyceride, which is triglyceride is the chemical name for the oil. For the oil, it's a common name. Convert into the fatty acid metaester, which is fatty acid metaester, also the scientific name for the biodiesel. For the biodiesel. So how many percent? Because during the process, certain percentage will be converted already. So the true process to convert into the biodiesel is called it the trans-esterification, which later on in the following study I will show you in more details what is the process and different processes. Then in that study we found that if we have the particle size between 1 and 2, we can get more extraction efficiency. That means we can get more oil extracted out compared to more than 2 ml. You see, this one also has the significant impact. So during your study, don't mix up the any specific parameter might be possible affect your result. We don't know. We just try. We don't know. We just try. Oh, particle size. Maybe we just think that particle size will not have any effect, but you can go through the experiment to prove that they have the effect or no, don't have any effect. That is the thing. We don't know. Then we just try. Oh, we found that they have the big significant effect. Because why? If more than 2 mm, the mass transfer is limitation, because difficult for the solvent to penetrate with the samples, with the samples. So with more even less than 2 mm, I mean between 1 and 2 mm, 2 mm, mean we have the largest interface area, then facilitate the oil extraction. Then after that, even we try even find go less than 1 mm, they are nothing much different. Because that is the optimal already. Nothing much different. Because if they are the 5 particles, maybe all your sample will be together already. Then make it the space don't have the larger surface area already. I mean this is the maximum limitation that the ultrasound can penetrate into the particle size. So that means we know that 1 to 2 mm is one of the optimal condition. We don't need to go into the smaller particle size. So this is one of the way to do optimization. Fix the different result. You have to see. This is for the Jatopa. This one is for the Jatopa. So this is one of the way I can do the optimization. We fix the other parameter first. Other standard parameters. That is the parameter that we fix. Then with the vary. So we can do one by one. This is one of the way to do the optimization. Then second, that is we can use the difference acid sulfuric loadings. Acid sulfuric, we use the acid sulfuric as the what? As the our catalyst. As our catalyst. So with the particular size, we fix as 1 to 2 because we know that 1 to 2 is the optimum for the for this case. So after that, we increase the loading. We found that the increasing the loading, the extraction efficiency almost stagnant already. So we know that the acid sulfuric will not have any effects on the extraction efficiency. You see, from few experiments we can get many information, many information. So be more creative, in order to find out your output. You see, this one, just one experiment, we have 3 output. I draw out 3 different output. First output is what? The extraction efficiency, how many percent of extraction? Because sometimes, as I told you, they are not much different. Then second, the esterification efficiency. Esterification, how many percent of the acid value will be reduced? Last one, the frame year. We can study the what is intermediate result. Yes, we are not necessary to get the frame year at this moment, because the frame year we can get it after the esterification to make sure the frame year is more than 5% is sufficient. But we study because why? We want to investigate. We are the researchers, we are the scholars. We want to investigate every single parameter that might be have the effect. Then we found that if increasing enhance more esterification reaction. Of course, this one we know from the chemical reaction. We know that if more catalyst loading on the process, the process will be more efficient. Correct or not? More efficient until the certain optimum value, which in this case is up to the 5%. So for the esterification process, that means the sum of the triglyceride will be converted, or free fatty acid will be converted into the fatty acid medium ester directly. So we know that the frame year might be much more affected, much more affected. Because why? You see, from here to here, you see, there are the significant change. Why? What happened? This one, I told you that the esterification efficiency is that the acid value, the conversion of the acid value. This one from here to here, we know that we can make the assumption that some of the FFA or free fatty acid are converted into the frame. So that's why from here to here, you see the acid value are reducing. Reducing, that means what? The efficiency of the esterification efficiency is increasing. It means acid value is reduced. And until the certain, the acid value are almost maintained already. But if we prolong the reaction time, the esterification process, transcription process is a reversible process. The reversible process. If you go backwards, backward process as well. Okay, then until here, we found that 5% is the optimum. We can get the frame years at 16.73%. So throughout the process, the water will be produced as a byproduct. That process, esterification, water will be produced as a byproduct. Water will cause the acid value increase as well. So this one is what we have the particular. In this study, we conducted more experiments, but I just show you a few experiments only. So this one is I think the last one for the esterification. This is the effect of the reaction time and also the ultrasonic amplitudes. How many percent of the ultrasound can we break? We use the 40%, 50%, 60%, 70 and 80%. 70 and 80% is good. We know that the frequency is higher. That means what? The ultrasound can reactive and penetrate directly to the sample. Correct. That's the thing. But we found that overheated, our overheated and make the overall temperature also increase. It's not good. It's not good. Overheated. And also if more than 60, more than 60 degree also not good, because why? More than 60 degree, the methanol start to evaporate already. The methanol will not have the reaction with the sample already, because evaporate. So, and also so that we found that the 60, even though the higher frequency, the higher reaction time, the frame year will be keep increasing, but we take the 150 minutes and also the 60 degree as the optimum conditions. Yep. And also, yeah, we found that, you see, if we are using 60% of the amplitude have the highest what faster rate, the reaction rate is much more higher compared to 40 to 50 degrees C. Yep. So this is the optimum condition that we obtain. Which is the particle size 1 to 2, 3 to 1. Yep. You see. Initially, this is the outcome that we get. The extraction efficiency is up to 83.96%, which is higher compared to the mechanical extraction process. Mechanical extraction process. In this study, I didn't show you what is the. So I don't know. I compare or not. We compare, but maybe I didn't show you here. We didn't show you here. Maybe can go to that paper, because we compare between the traditional process and also the this process. The extraction efficiency is highest, and also the esterification efficiency. Extraction is almost similar, but extraction efficiency is much more higher. So since since the esterification efficiency is 71%, which the acid value still more than 4. You see, as a good time for the biodiesel production, if the acid value is more than 4, that means what? What happens if we use the alkaline catalyst, alkaline acid neutralization? So soap will be produced. It's not good. So that's why in this case, so we use the slightly lower KOH to avoid the soap production. Then with the reaction time with only 50 minutes, then we can achieve that frame year. This one we also study the this is there is the benchmarking study that we initial study that we take the parameters. Then after that, you see. Then after that, we study what is the effect of the KOH, which is the alkaline catalyst. With the additional of the catalyst, the sulfurification process will be happen, correct? Make the product very difficult to separate. The soap will be happens. So the frame year will be decreased beyond the 1.5%. Then solubility of the frame in the gas oil is increased as well. So that's why in this case we take 1.5% of the catalyst loadings. Then from here we study the frame year and also the biodiesel year. You know what is the biodiesel year already? Okay, then the frame year. This one is what the effect of the methanol to the actified oil molar ratio. So from 9, 12, 15, and 18, you see, by the chemical reaction, we only need 3 more, 3 more of the methanol. But as I told you, the trans-activation process is reversible process, the reversible process. If you just put 3 more, not all the compound or the triglyceride can push toward to the right hand side. the reversible process will be happen. So that's why we need to put the extra methanol. Then after that, we need to recover back the methanol. Recover back the methanol. Yes. After the process, I need to recover back because by schematic chemical process, only we need 3. This is the ideal case. Not going to happen in the real situations. We need to use the extra methanol, which we use up to 12%, 12%, so that we can see the optimum condition. So beyond the 12%, we have the over dissolution of the biodiesel and also the glycerol, because it's due to the shifting of the equilibrium toward the reactant side, which reduce the overall efficiency because this is the reversible process. This one is what the effects of the reaction time and also the ultrasound amplitude on the film purification and also the biodiesel yield. So we found that the reaction time just 15 minutes can be complete the reaction. Yesterday I think I showed you the biodiesel production. Yesterday. It takes up to how many minutes? 60 minutes to complete the reaction, but the ultrasonic we only need 50 minutes. Yeah. So the ultrasound also able to enhance the overall efficiencies of the process. So this is the overall final result. Then final result, which the acid value able to reduce up to 88%, which the film year we achieve 99%, and also the biodiesel year is 85%. 85%. Biodiesel year is compared to the raw material. Compared to the raw material. Then in order for us to commercialize the biodiesel, we need the film year more than 98%. I mean, film year, that means what? For your biodiesel, that means at least 98% is the fatty acid material. Yeah, it cannot be has other compound. This one, of course, we need to measure by using the GCMS. So this is the list of the parameters and also the standard SDM standards. Oh, I didn't show you the standard, right? Because for any test method, for example, the density, the acid value, the fresh point, the calorific value, this all we not to say simply measure. They are a lot of the method for you to measure. We need to follow the ASTM or EN standard. The measurings or the test method. We need to follow the certain test method. Because example, density. You can measure the density at 40 degree, 50 degree, or any temperatures and any conditions, or the room temperature. But according to the ASTM standard, we need to measure at the 15 degrees C, so that the 15 degrees C it can be fulfilled at the certain density value. Yeah, this is the test method. This is also very important because if you conduct the scientific research, the examiner normally will ask you, what is the test method you are using? The test method standards. Test method is first thing. Second thing, what is your benchmarking study? We always must have the benchmarking study to compare as a baseline study. Your baseline study. What is your baseline study? How you make the comparison? This one is very, very important. So baseline study. So this is some of the properties which the acid value still highest. You see in this study, the acid value that we conducted after the final product is still higher. We are able to publish as well because this is our result. This is our result. Not really fulfilled. This is our result. This what we get. It is above the, because maximum can be 0.5 only, but can be used or not can be used. But if you cause the wear and tear in the engine component parts. Yeah. Okay, that one is based on the final biodiesel that we're using. For example, you see, even though this one is based on 100% B100, I mean 100% of biodiesel. If you mix with the maybe 80% of the diesel with 20%, the overall acid value maybe might be 0.4 or whatever. Yeah, that's the thing. It means what? We cannot use the 100% pure biodiesel. This cannot be used in the system. Yeah, that's the thing. There are no tolerance, and no tolerance for what? If we are using in the vehicles, no tolerance for the car manufacturer, because no at all, because they will not have the warranty. We discussed with the car manufacturers, many different type of car manufacturers. So this is one of the very big hindrances also, because the car manufacturers will not have the warranty if you use a certain percentage of the biodiesel or whatever. Yes, that is the thing that you need to take it carefully, you know. Yeah, that's the thing. Car manufacturers is one of yeah. Not only so in order for us to develop a policy, it's not really easy. So many stakeholders involved, you know. Yeah, many stakeholders. That's the thing. So in Malaysia also same thing, because the maximum they allow us, the car manufacturer allow us is 20%. Because beyond that, they say no more warranty or whatever. Yeah. At this moment, but throughout the time, maybe the biodiesel that we produce is, as I mentioned, is closer to the fossil diesel. Then can be possible. Can be possible. As far as possible. So this is the conclusion. Conclusion is just normal, because we found that the parameter we already discussed in details for the acidifications and transacurations. Then this one I didn't show you. The seed particles were found to have smooth and intense surface before applying the ultrasound. After applying the ultrasound, disturbed and also the irregular surface was observed. It means what? The irregular, that means what? The ultrasound able to break down the seed matrix, the seed matrix of the particles, so that it can be easily to be the thermal degrade. Can be easily thermal degrade, because the ultrasound go through the sample directly. Then this one fulfill the accept acid value. We just report whatever that we found. And with this result, we are able to publish two papers. First is the paper number 1 and number 3. So just now, understand from you all. So most of you are master and PhD student, right? You want to know how you're going to turn your research into the publication. Then how you're going to turn your publications into the thesis. Very simple, very easy. Very simple, very easy. Oh, you want to know or not? This thing. Yeah, very simple. Very simple and very easy, you know. This one. This one can be right or not, but this one is for whiteboard or not whiteboard. Okay, you see. No matter you are the master study and or PhD study, the difference is what? The depth of your the study, correct not? The depth of study. In your master study or PhD study, you might have how many objective? Maybe objective 1, objective 3. Some have 4 objectives, correct not? 1 or 2 or 3, 2 or 3 objectives. Very simple. If you have 4 objectives, let's say 4 objectives, these 2 objectives, you conduct the experiment or whatever, you come up with 1 paper. You count 2 paper. Then how you convert in this paper into the thesis? For our engineering, the thesis is very simple, very easy. Standard format. A very, very standard format. What standard format? First one is what? Instruction. Instruction, you have what? Your objective, your problem statement. Problem statement, your objective, correct or not? Your objective. Then second, what is the second chapter? Literature review. Fair enough. You have to conduct your literature. Third chapter, methodology. Four, sometimes your four is a result and discussion. Some you divide into a chapter 4 and chapter 5. Result, discussion, right not? So I make it one chapter. One is conclusion. Right not? Reference. Correct not? So you see, many of the students, they tend to complete everything first, you know. Complete all the experiment, then start writing. Then at the end of the your study, cannot come up anything. You forgot what you got already. So or don't know how to start, the writing. Got too much already. The one thesis need 100 pages, to PhD maybe 150 pages. So don't know how to start. So don't write at the end. You write after you conduct part of your experiments. You record down first. Record down not necessarily to turn into the papers. Record down, that means you turn your result, the data. You turn into data into the table or figure. Don't let your data in the raw data yet. Turn into the tables and figures. Turn into the table and figure first. Then start to write out the big things. The big things. Then after that, you come up with one paper. Then second paper, if let's say, or each objective. If you are the PhD student, your objective is you study more in depth, correct not? Each objective can be write one papers, or two objectives. First two objectives, one paper. Then third objective, another papers. Fourth objective, another papers. Then after that, if you have this thing already, turn your thesis. Very simple. Within 1 or 2 months, you can make it. Objective from here, from paper 1, objective right here. Four, objective from here. Then your methodology, section 3.1, overall. You need to connect everything overall. You write overall. Then 3.2. 3.2 is what? You match back with your objective. 3.2 is what? The method that you conduct. Method is a much more easier part that you can write, you know. 3.2 is whatever that you conduct. 3.2 is what? Match back with the objective number 1. From where? From this paper. Then you have the 3.3, 3.4 or 3.5. But only thing that you need to do is what? How to make it connect. Like a story, right? Then from here, you see, from paper, from here, you have already. Then result and discussion. So 4.1, overview, what you need to write for your thesis. Then 4.2, 4.3, 4.4, and 4.5. From where? From here. From here. This is what I teach my students. Then conclusion. 4 objectives. One is the instructions paragraph. Then 4 objectives. We write 4 paragraphs. From where? From here. Then the only thing that you need to do is connect them. That's it. Your thesis come out. Simple or not? Simple or not? So once you conduct the experiment, table up your raw data, your raw data into the tables or proper figures. Then start analysis. See what type of analysis. Make the comparisons. Of course, before you start, you need to do what? Digital study. To figure out what? Do the digital study to figure out the get. What is the problem statement? Then what is the get? That is the thing. That's another thing. Do the digital study. So digital study also, you do from time to time, not until the very end. Very end already, you already conduct everything. Then every digital review is no longer new for you. You have no interest to write. Correct not? You are lose interest. Oh, I need to write this one. I already know. This one I already know already. That you write record down from time to time. That's the thing. This is the thing. This is how we turn the research into the papers. Then from papers turn into your thesis. Then at the same time, do your digital study, detailed research study, update your digital study from time to time. From here, you figure out the problem statement and also the significance or the novelty of your study. Novelty, then I stress again the novelty. So novelty is not if you are able to create something new, it's good. It's very good. The novelty and the significance is what is the improvement of your study. The improvement, every improvement are counted, you know, every improvements are counted. Yeah, what any innovative idea, innovative improvement are counted. So what is the improvement compared to previous study? Previous study means what? You do your benchmarking study, you do your digital study. Oh, they want to conduct this thing, but I have an idea. So how to design my process? Design my thing. That is the improvement. I'll see what is the improvement after you conduct experiment compared to your benchmarking study. Yeah, that's the thing. So any questions so far? As wait, which one? Which one? You go to a slide. Which slide? This one is increasing. What is your question? I can't understand your question. Sorry. Oh, side product. Yes, they are. They are. But I didn't record down. Yeah, I didn't report here. They are. The waters, other impurities. Yes, they are. Water. Gasoline also. Yes. Yes, they are. They are. In the thesis and in the paper, in that paper, we discussed this year the glyceride, how we separate the water and glyceride. We do separate. Have to separate. If not, cannot get the high purity of the fatty acid medium ester. Then also sometimes we do the washing also, because this is in the industry they are not ready do the washing. They just do the separation only. The washing, because experiment, because we are conducting research, we want to see after we do the washing whether we can wash out the impurity or not. And after that, there are still many things can do. After wash out, we can analyze what is the impurity that we wash out. If someone really need to investigate in depth, what is the impurity inside there. Then from there, maybe we can design the process so that the impurity cannot not appear in the final product. Yeah, that is research. So it's very fun. And yes, NOx. Okay, because this one, this study, we focusing more on, because the production side. For my group, we do the combustion side also, you know. But I didn't show anything about the combustion side here, because the background of the people here is totally different. We do, but I can briefly share with you. The NOx emission will be increased. No matter what is the biodiesel we are using, increase. But the percentage is not high, but increase. The NOx emission increase. We do on the engine combustions. We do the combustion test, increase. The NOx increase, but other emissions reduce. Yes, NOx increase. Yes. NOx increase, NOx increase, NO increase, and N2O also increase. Yeah, it's increased. It's increased, that one. We do have other study on that, but I didn't. This time I didn't show anything about that. Yeah, it's increased, not increased. So, oh, N2O. Oh, no, it's the nitrite oxide. Nitric oxide or something like this. Yeah. Nitric oxide. Yeah. Any other questions? Oh, yeah, just now I mentioned the test method. So for every experiment, if for those are the PhD or master scholar, for your every methodology or every method, you need to know what is the standard test method you are using. Then people ask, what is your repeatability? The test methods. Every testing, they have the standard test methods. You know, what is the test method you are following? Why? Because if not, first time or first time experiment, you follow this test method on your own way. You design your own test method. Don't know what is the test method you are doing. Then the second batch, you using the second test method. The third one, and cannot be consistent. Must have a very consistent test method. No matter what is the test method you are using, as long as you are able to justify. Yeah, must be able to justify. So this is the test method we are following for the certain experiment. Each experiment, we have the certain test methods, standard test method. Yeah, that's the thing. See what else I can show you. This is the study. So you see, every time before we start the study, we also determine the compositions, that element analysis and also the polymer analysis. Yeah, CH, CSN, and O, H content. This is another effect which I didn't show you in the main slide. Yeah. Element analysis, you see the NOx, nitrogen, the element we have. Normally it's less than 10%. We found that less than 10%. Still have. Yeah, that's the thing. We still have much more result here. I just show you some brief result. So any other questions? Yes. Marine field. Yeah. I didn't study on the particular study on marine field. Yes. Yes, correct. Yes, different. Lower than laser. Yes, lower than laser. Yes. Yes, correct. Okay. Okay. Yes. Yes, correct. Correct. True. And also, not only that, there are a lot of the industry use in their generator as well. You see construction, they are on site. They don't have any electricity during the construction. They use the generator instead. That one also using a lot of the diesel as well. Construction. Yes, normally, so that's why the biodiesel is very safe, because the fresh point very high. Normally, fresh point for the biodiesel is very high. Fresh point. Fresh point is different with the ignition point. Ignition point. The ignition point for the biodiesel is not very high. It didn't burn, but the ignition point for the bio oil is very high. Sometimes it's very hard to burn. Sometimes it's very hard to burn. The ignition point and the fresh point is two different things. So any other? Yes. Okay. No, I didn't say the hydrothermal is better than the ultrasound is better than the hydrothermal. What I want to introduce is the compared to the traditional process, how we embedded the advanced technology. For example, using the ultrasound in the trans-esterification process. Yeah, that's the thing. I didn't mention that the ultrasound is better than the hydrothermal because our target product is different. Target product for the hydrothermal is different. Yeah, hydrothermal can get maybe the green diesel or whatever. Maybe for their fixed oil is different. Their process is different. Yes. You mean extraction efficiency? What is your question? For the hydrothermal is you need to make sure what is the target product of your hydrothermal. For example, for me, normally, I use the hydrothermal to do the treatment only. I didn't focus on certain product yet, you know. Do the treatment, I mean treat the waste only. For hydrothermal, normally I used to treat the waste. Then treat the waste, then we use the very typical process, then see what is the product that we produce first. Then we focus on the product, see whether that product can be turned into something valuable or not. This is what we are doing. So our is first thing, do the treatment. Then after that, from there, we see what is the value-added product can be produced. Then we focus on to convert that value-added product into something useful. And to close the loop. Close the loop, I mean, do the treatment as well. Then we have some product to produce. The byproduct can be produced. Yeah, that's the thing. Then for this process, we purposely design so that what it can produce the high biodiesel yield and pure biodiesel yield. Yep. For other data, I mean, maybe tomorrow I show you what is the hydrothermal process. Our hydrothermal process, I didn't focus on the certain product. We just see what is product and how we are going to utilize the product. I will show you. That's the thing. I didn't focus on products. Then some is some we focus. For example, the pyrolysis process. Oh, we focus. We want to produce the bio oil. That one is particular. We focus. Then some is we just want to do the treatment only. Because different process, different things, we cannot compare directly. See what is your needs and demands. Need and demands. Depend on needs and demands. So can play around because you are the master and PhD student. Just play around with a lot of the experiments. Because for me, I like the experiment because with the experiment we have a lot of data. Because now the current scholar they like to do the simulation. For me, I also start the simulation, but no matter what simulation I'm doing, I will do the experiment data to verify to develop. And after the simulation data only pave at the fundamental research so that I know this process, this design, this concept is work. And after that, I'll go back to the experiment as well. I don't need to do a lot of experiment. I mean the unsuccessful experiment before I conduct the experiment. This is the tool of the simulation. But now I found that many of the researchers and the scholars, they tend to do the simulation. Yeah, because why? Fast. No need to go to a lab. No need to set up the thing. Set up the thing. Maybe take design the reactor. Take maybe half year to 1 year. You know. Yeah, that's the thing. Very hard, but worth to invest. For those want to be a researcher or academic staff, it's worth to invest your time on that. You know, they want to pave a very strong foundation for your future careers. If you want to be the academician or researcher, if you just want to get the PhD or master. Doesn't matter. You don't need to do. And then after that, you want to be the investor or you want to come up with one product. You don't need to go into the field. Yes, but for those are interested to be the academician, to be the researcher, this one is very important. And that is very important. The curiosity, the interest for you to do. Compare what you compare with the simulation and also the. Very can because you want to design with the different process. Yes, this very same raw materials, totally different process, but your target product is the same, maybe same, or different also doesn't matter. If you have the certain target product, then you can compare with the certain with the process, then with the certain target product. If you don't have the certain target product, you can just compare with the few methods. See what is your product that you produce, which one can produce more higher values product. That one also can. It depends on you how you're going to justify. So for research, you know, there are nothing wrong and right, but we must have the critical thinking. We need to know what we are doing, what is the justification behind. Not because of my supervisor asked me to do so. My supervisor, then during the defense, my supervisor asked me, so I only have this equipment. That is not the very answer. You have to know clearly what is the justification. You do the certain experiment, do the certain thing, certain testing. This one you have to know. That's the thing. Then the other thing you can do on the path A, B, C, doing research like go to the maybe I want to go to that directions, to that way. You can go here, then round there, go here. Nothing wrong and right. Nothing wrong and right, but you know. Then, but your destination is go there. You must always know your destination is go there. Don't lost somewhere else, you know. Yeah, go there. But follow this path. It's up to you. But you must know why you go from this way to that way. What's your justification? Yeah, you have to know. That one you have to know. So any other questions? Which one? Oh, copper strip corrosion. Okay, that one. Because previously I mentioned that the biodiesel generally have the higher acid value will cause the wear and tear in the engine component or genset component part, the wear and tear on the part and components. So copper corrosion is to see what is the corrosion level of that fuel. Yes, this is one of the properties that in the EN standard, but this is not a very crucial property. It's one of the properties only. Yep. The crucial properties for the biodiesel is what? The acid value, the film content, density, viscosity. Then sometimes oxidation stability. If some oxidation stability is too low, then the other is just the supporting parameters. Yeah, supporting parameters. But the acid value, viscosity is very important. That one is very important. Then some also measure the water content, because the water content must be less than certain percentage of the water content. If not, also will cause the some wear and tear on the engine part and components. Yep, this one. Because it cause a corrosion. Why corrosion come from? Acid value. The acid value. The acid, yeah. I have many different study. All my, but I don't know which one is within your interest. So today I also prepare another. Just now I mentioned I want to show you two study. This one also using the ultrasound. Also for the biodiesel, we using the span coffee ground, because you know I don't know in India, in Malaysia previously we are not really drink the coffee, you know, but recently for the last 5 years the people drinking coffee is increasing, you know, a lot, a lot of coffee shop, cafe or whatever drinking the coffee. So make me have this idea to have the span coffee ground, you know, for the for two products. I target two products. One is the initially the biodiesel, then secondly is for the biochar. Sorry for that, biochar. I have two targets for this study. Target is the biodiesel. How about India? India also increasing a lot. The last time don't have, right? Increase, right? Previously a lot of Starbucks and other type of the coffee shop are similar to Starbucks one. Yeah, in Malaysia also same. Recently, this 5 to 10 years I can say, starting to 10 years back is starting. Then now the last 5 years is a lot increasing. So many, right? A lot of drinking. So this one is one of the problem in the future also, because why? Some of the that cafe or the cafe they find us, say they have a lot of the this one, the spent coffee ground. So how we can make it sustainable in line with the SDG, you know. This one we conduct this topic before they find us, you know. They find us. This one is 2018. Then recently, few of the cafe, the chain cafe, the large chain cafe, they start to think how they can utilize this spent coffee ground, but mainly two purpose, two products they can produce. One is to extract out some of the biodiesel or biofuel to convert into biofuel or biodiesel. Another one is what can be converted is biochar as a biofertilizer to use back in the plantation or agricultural areas. So both I also studied today. This one is tomorrow I will show you about the biochar one. Then today is about the biodiesel. The instruction is the same thing, first two generations. Then this one, now this is some of the statistics. Statistics. They are this one in 2016, 8 million tons of the coffee produced. Then produce 65% of the waste residue. 65 out 8 million tons, 65% is produced. Okay. What is the? Yeah, you see, the coffee. This one is the why is it? Oh, this one. Oh, I think it's already run already. This one should be 42%, 25%, 25%, 18%. I mean, around 42% of the semi-cellulose. Then the cellulose is 13%. Then 25% of the lignin. Lignins. We talk about the lignins. Lignin is the compound or the component is very hard to degrade. Degradation, yeah, because normally can easily degrade the cellulose and hemicellulose. So that's why, as I told you, we need to know go back to the fundamentals of the or characteristic of the biomass. If we know the lignin is very hard to degrade. It needs to degrade at very high temperatures, lignin. So normally, so we prefer to find the biomass that has a lot of the cellulose or hemicellulose. More better, yeah. It depends. It depends. Some, if you can able to find one method, to degrade the lignin to something useful, that one is also very good. What for our group, yeah, this is not our directions. So we didn't study much more on the lignin. We just leave it, but we know that still something not degraded. That one is a lignin. This coffee, smell, yes, yes, yes. These are general compositions. It is in these three compounds. These three, I mean what? Cellulose, hemicellulose, and lignins is available. That is available in most of the organic biomass waste. Organic biomass waste. These three. It just depends on the composition. Which one is higher, which one is lower. Yeah. Yes, they have. Yeah, maybe I don't know what's their lignin percentage. Yeah, but they are these three. That are the three main components for the biomass. Yeah, there is the problem statement. You have to know the problem statement. Then come with the objective. We need to see what is the effect on this. So yeah, that is the instruments in our lab. So that's why in our lab we have quite complete facilities for all the bio oil or the solid product analysis. Solid products analysis. Not only this one, we still have the we also have the TGA, GCMS. This one is the GCFID. Then we have the GCMS as well, viscosities, the boom parameters, so acceleration, stabilities. Yep. Project method is almost similar, but one thing is the difference for the spent coffee ground. The acid value normally is low, so that's why we no need to go through the acid acidification process. moisture content. Of course, they have very high moisture after the spent coffee ground. This ultrasound, this is a solvent. Oh, this one we compare two method, not that study. Then we compare two method. One is solvent attraction, one is the ultrasound attraction. What is the difference? Yeah, this one. So just now I mentioned to you. Yeah, I still remember one candidate asked me. So what is the different other process? We have the, because normally in the industry currently they tend to use this process. Using the homogeneous catalyst process, because why? Higher low cost. Industry like it, higher low cost. But what is the drawback? Drawback is what? Difficult to recover the catalyst. Don't need to, the industry don't care, because why? The catalyst is very low cost compared to the product, and also the wastewater. And we need the purification step. That is the drawback. Then they are pro and cons for the all other process. So as I mentioned to you, the from the scientific way, the preferable process is what? Non-catalytic supercritical, which is the high pressure, high temperature. You see, it's super fast process with the higher, can be convert FFA. There are no any catalyst needed. Then can easily produce a very pure product with no any waste. But this is due to high temperature, high pressure, and high initial cost. High initial cost. Yeah, that's the thing. That's the thing. Yep. Then the enzymatic reaction is what? Enzymatic reaction is a totally clean process. Not using any chemical. But what? The process are relatively slow with the high cost of the enzyme. So I think I would stop here. So any questions before, and this one I will continue tomorrow. So any questions? This study, I have too many things to share. This study, what we do, you see, just now, just I mentioned, we use the jatopa. We use after that, we convert that jatopa, the oil jatopa after biomass, then convert it into the what? Catalyst. The biomass convert it into catalyst, then use back in the reaction. This one I will continue tomorrow. Become carbon-based catalyst. So how to activate catalyst? How to convert this one into the catalyst? Yeah, that study. Okay, any questions? I think I will end here today. Any questions? Okay, if not, we'll end here. So thank you for your attention. Then yeah, that's all today.
Thank you all. Now we will go for a lunch break. So lunch break will be from exactly for an hour, and later we will inform you regarding it. So we'll go for lunch now.
So we'll now disperse for lunch break, and post lunch Professor Ang will be here up to 2 to 3:30 for informal discussion. It's not mandatory. If any one of you want to discuss with him regarding research or his experience, he'll be here up to 3:30. So post lunch we can assemble in the same hall for the discussion. Those who want to leave, they can go back to your respective rooms. Okay.